For part A of question 1, I need all the integers between -2 and 3. -2 is included in this range, 3 is not. So I have -2, -1, 0, 1, and 2. And then for part B, I will have a circle at 1. This circle is full because 1 is included. And then I'll have an arrow pointing to the left, which includes the numbers less than or equal to 1. For question 2, I'll just multiply 300, which is the times the game will be played, times 0.65, which is the probability of a win. This will give me 195, which is my final answer. In question 3, I'll work with this triangle and I will try and find the base. Let's call this x. So let's extract this triangle. Using Pythagoras theorem, x squared plus 12.8 squared is equal to 16 squared. Rearranging gives me x squared equals 16 squared minus 12.8 squared. So x squared is equal to 92.16. X comes out to be 9.6. Hence, if I want to find this distance here, let's call this y. All I need to do is subtract x from 12.8. So y equals 12.8 minus x. That's 12.8 minus 9.6, which comes out to be 3.2. So to find the perimeter, I will just add the 3/16. I have the 2x's and the y. So perimeter equals 16 times 3 plus 2 times 9.6. Those are the 2x's plus the 3.2. That is the y, and the sum comes out to be 70.4 centimeters. For question 4, just plug in these x values into the equation and get the y values. These come out to be 15, 0, minus 1, and 3. And then in part B, I'll need to plot these points. Let me zoom out a bit. And then I will join them with a smooth curve. In question 5, I am given 5 out of 8 exam marks, and I need to find the missing 3 marks based on these characteristics. Because the mode is 80, that means I will have at least 180. And the question now is, do I have a second 80 or not? And if I assume that there is another 80, then to make sure that the range is 16, means that the difference between the smallest number and the largest one must be 16. So the smallest number must be 64, which makes the median to be 76. That's the midpoint of 75 and 77, but the median is supposed to be 74, so there is no other 80. To find the median of 8 numbers, you'll divide 8 by 2, which comes out to be 4. Hence, the median is the midpoint of the 4th and the 5th observation. And because our median is 74, it means that I should have an extra number in here. And in this case, either 72 and x will be the 4th and the 5th, or x and 75 will be the fourth and the fifth. Obviously, 72 and x can't be the fourth and the fifth, because even if I add another number at the beginning, 72 will be the third number, which means that x plus 75 over 2 will be the median, and if I solve for x, I will get 73. Finally, because the range is 16, means that 80 minus 16 will be equal to 64, and that is my third missing number. So 80, 73, and 64 are the three missing numbers. For part of question 6, I'll start by writing 36 and 120 as the product of prime numbers. So 36 over 2 is 18, over 2 is 9, over 3 is 3, and over 3 is 1. Let's repeat for 120, divided by 2, 60 by 2, 30 by 2 again, 15 by 3 will give me 5, and then 5, 1. Hence, 36 is equal to 2 to the power of 2 times 3 to the power of 2. 120 is equal to 2 to the power of 3 times 3 times 5. And to find the lowest common multiple, I'll take all prime numbers. So 2 times 3 times 5 to their highest powers. Power of 2 is 3, power of 3 is 2, power of 5 is 1, and this will give me 360. In part B, I need to find the highest common factor of A and B. I note that A and B have 5, 7, and 11. So 5 times 7 times 11. And then I need to find the correct powers, and this will be the lower power for each base. For 5, I have 2 and m, but m is bigger than 2, so I'm going to take the smallest, which is 2. For 7, I have a 4 and n minus 5. Note that n is bigger than 10, which implies that n minus 5 is bigger than 10 minus 5. Hence, n minus 5 is bigger than 5. Hence, the power of 4 is less than n minus 5. And for 11, here I have a power of 1. Here I have a power of p where p is bigger than 1. So 1 is less than p, and that's my final answer. For question 7, whenever I have distance, speed, and time relationship, I use the following. If you want to find the distance, that is speed times time. You want to find the speed, is distance over time. You want to find the time, that's distance over speed. Now I can't add the speeds, so I will add all the distances, all the times, and divide the two. To make my workings more presentable, I will create a table. So for A to B, the distance is 245 and the time is 2.5 hours. For B to C, distance is 220 kilometers and the speed is 80. Now you can use distance over speed to find the time. So the time is 220 over 80, that's 2.75. And then for the last part of the journey, I have a speed of 72 in 50 minutes, and that's 50 over 60 or 5 over 6. To find the distance, you just multiply speed times time, and this comes out to be 60. So if I add the distances, I get 525. If I add the times, I get 73 over 12 from my calculator. So to find the average speed, just divide distance over time. So that is 525 divided by 73 over 12, and this will give you 86.3 kilometers per hour, and that is to 1 decimal place. For part A of question 8, that's 5 with 4 zeros. For part B, I have 6 times 10, and because I have 5 zeros, it's going to be to the minus 5. For part C, it might be easier to write this as a fraction, so 4 times 10 to the 512 over 1.6 times 10 to the 700. Now, if you divide 4 by 1 over 6, you'll get 2.5, and then here you subtract the powers and you get times 10 to the minus 188, and this is the final answer. In part of question 9, you will add the powers, and this will give you x to the power of 9. In part B, let's split this. That's 4 to the power of 3 times y squared to the power of 3. The first one, can put this on the calculator, it will give you 64. And for the second one, you multiply the powers, so y to the power of 6. For part C, the two factors you get is n minus 4 and n minus 3. For question 10, there are many ways to solve this question. I will start by finding the area to be painted. So I've got 2 of those red rectangles, 2 of the blue ones, and 1 purple one. So area to paint is equal to 3 times 2.5 twice, plus 3 times 12 twice, plus 2.5 times 12, and that's only once. This comes out to be 117 meters squared. Hence, the number of tins required can be found by dividing the 117 by the 15 meters square per tin. This will give me 7.8 tins, which implies I'll have to buy 8 tins. To find the price of each tin, I'll use the fact that there is an increase by 10%. This means that I have a multiplying factor of 110 over 100 as a decimal as 1.10. Hence, price of each tin can be found by using the formula original times the multiplying factor gives me the final price. So original price times 110 equals 26.95. So the original price is 26.95 over 1.10, which comes out to be 24.50. Therefore, the cost of the paint is 24.50 times 8 tins, which is equal to 196, which is less than 200, and that's the end of the proof. In question 11, to find the area of the sector, I'll use the following formula. Now, theta is 110 and the radius is 7.1. You put this on the calculator, you will get 48.4 to 1 decimal place. Note the mark scheme accepts answers between 48.3 and 49.2. For part A, I'll start by expanding the two brackets. So this is equal to n, 3n squared plus 5n minus 12n minus 20. If I simplify, this will give me 3n squared minus 7n minus 20. And if I expand further, I'll get 3n to the power of 3 minus 7n squared minus 20n. For part B, the new denominator will be 4x. So I will need to multiply the first fraction by 4, the second one by 2, and the third one by x. This will give me 12 plus 2, x plus 2 plus x. If I simplify this, 12 plus 2x plus 4 plus another x over 4x. And if I collect like terms, this will give me 3x plus 16 over 4x. For part of question 13, I need to complete the tree diagram. Now, since this probably is 7 over 12, the one below will be 5 over 12. And then note that because we are replacing, all these pairs will be exactly the same. So I get 7 over 12 and 5 over 12. In part B, I need the probability that both counters are red. So I need probability red and red. So I'll need to multiply these two probabilities. So 5 over 12 times 5 over 12 is equal to 25 over 144. For part B, you'll need to consider another set of branches at the end of each outcome of the second counter for Hector, and this will look like this, where B, G, and R are the number of blue, green, and R counters in Megan's jar. Now I'm being asked to find B, and to do so, consider having these three branches at the end of each of those outcomes. And since 7 over 24 is the probability of the three counters having a different color, it means that since Hector doesn't have any blue counters, the blue one will come from Megan. So it's either going to be green, red, blue, or red, green, blue. So I'm going to add those two combinations, equate them to 7 over 24, and find B. So probability green, red, blue plus probability red, green, blue must be equal to 7 over 24. So 7 over 12 times 5 over 12 times B over 15 plus 5 over 12 times 7 over 12 times B over 15 is equal to 7 over 24. Now if I simplify the first bracket, that's 35B over 2160. The second bracket is exactly the same, equals to 7 over 24. I can add the two expressions on the left. I will get 70b over 2160 equals 7 over 24. Hence, b is equal to 7 over 24 divided by 70 over 2160, which comes out to be 9. For question 14, step number 1, recognize that this angle ABC is equal to 90 degrees because angle in a semicircle is 90 degrees. Step 2, ACB, which is this angle here, is equal to 180 minus the 90 and the 55. Because angles in a triangle add up to 180, it will give me 35. And finally, angle 3, which is ADB, is equal to 35 because 2 and 3 are angles in the same segment and hence they are equal. So let's write all this down. ABC equals 90. Angle in a semicircle is 90 degrees. Then angle ACB is equal to 180 minus the 90 and the 55. This gives me 35. Angles in a triangle add up to 180. And finally, ADB is equal to 35 degrees because angles in the same segment are equal. For question 15, let the three consecutive integers be n minus 1, n, and n plus 1. Now I need to show that the sum of squares of the smallest and the largest one is equal to more than twice the square of the middle number. So my target will be 2n squared plus 2. That's the middle number. Square it, multiply by 2, and then add 2. So n minus 1 squared plus n plus 1 squared is equal to n squared minus 2n plus 1 plus n squared plus 2n plus 1. The minus 2n and the plus 2n cancel out, and this gives me 2n squared plus 2, hence proved. Note that if your three consecutive integers were n, n plus 1, n plus 2, then your target becomes 2n plus 1 squared plus 2. So when you square the first and the third and you add them, you get n squared plus n plus 2 squared. Expanding will give me n squared plus n squared plus 4n plus 4. If I simplify, I will get 2n squared plus 4n plus 4. And to get to my target, I'll need to complete the square. So 2n squared plus 2n plus 4. Completing the square will give me 2n plus 1 squared minus 1 squared plus 4. This is equal to 2n plus 1 squared minus 1 plus 4. And if I remove the square bracket, that's 2n plus 1 squared minus 2 plus 4. And finally, this will give me 2n plus 1 squared plus 2, which is equal to my target, hence proved. For question 16, I have an arithmetic series. First term, a is equal to 1, and the common difference is equal to 4. I need to find the sum from the 41st to the 100th term, I'll use the following formula. And in order to find the sum from the 41st up to the 100th term, I will calculate the sum of the first 100 terms, that's from 1 to 100, and then I will take away from 1 to 40, so that is the sum of the first 40 terms. Hence, I'll be left with the terms from position 41 to position 100. So S100 is equal to 100 over 2 times 1 plus 100 minus 1 times 4, and this comes out to be 19,900. And then S40 is equal to 40 over 2 times 1 plus 40 minus 1 times 4. This comes out to be 3,160. And then I will subtract those two values and I will get 16,740. In question 17, I have this Venn diagram with three sets, A, B, C, and I need to find the number of elements. This is what the N at the beginning stands for in the set A union B. So A union B is this region here, and I have in there 6 plus 3 plus 8 plus 2, that's 19 elements. In part II, A intersection C, well, A and C do not intersect, so the answer here is 0 elements. In part 3, I need the number of elements in B intersection C dash. This means I want the elements that are in B but not in C, so these are the elements. So 3 plus 8 is equal to 11. And finally, in the last one, number of elements in A dash, union B dash, union C dash. Now, A dash is these regions in blue, B dash are the regions in red, and C dash are the regions in purple. And because I have union, that means I need all the regions with at least one color. As you can see, all regions have at least one color, which means that I have everything 4 plus 6 plus 3 plus 8 plus 2 plus 5, which is equal to 28. For question 18, I have surface area and volume of similar shapes. So I'll create the standard table I use whenever I have this type of problems. But this time I'm going to create it twice, one for shapes A and B and one for shapes B and C. For shapes A and B, I know the ratio of their surface areas is 4 to 9. Hence, K squared is equal to 9 over 4. Thus, K is equal to 3 over 2. And from the shapes B and C, the ratio of their volumes is 125 to 343. So K to the power of 3 is 343 over 125. You take the cube root, K comes out to be 7 over 5. So now I can find the ratio of the heights between A and B. This is 1 to 3 over 2. And the ratio of the heights between B and C is 1 to 7 over 5. So if I copy that first line, I will get the following. Now let's try and make everything into an integer. So I will multiply the first ratio by 2. So I'll get 2 to 3. I'll multiply the second ratio by 5. So I'll get 5 to 7. And the Target here is to make b the same, so I'll continue and multiply the a to b ratio by 5 and get 10 to 15. Multiply the second one by 3, thus I'll get 15 to 21. So the ratio of the heights A to C will be 10 to 21. For question 19 part A, I'll use the following two rules. 1 over x can be written as x to the minus 1, and the second one is the cube root of something is equal to that something to the power of 1 over 3. So I'll start by considering what is inside the brackets. So I have cube root of 1 over x, that's equal to cube root of x minus 1. And then using the second rule, that's x to the minus 1 all to the 1 over 3. And if I multiply these two powers, I will get x to the minus 1 over 3. Hence, I have a bracket to the power of 4, x to the minus 1 over 3 to the power of 4. Again, we'll multiply the powers and get x to the minus 4 over 3. And since this is equal to x to the power of m, that means m is minus 4 over 3. In part B, I'll need to complete the square. I'll start by taking 3 as a common factor. So I get x squared plus 4x, and then plus 19 outside the square bracket. Then I'm going to take this expression, come to the side and complete the square. So x plus half of 4 is 2, square minus 2 squared. So x plus 2 squared minus 4. That's my completing the square part. So if I get back, I'll get 3 square bracket x plus 2 squared minus 4 plus 19, which is equal to 3x plus 2 squared minus 12. I just expanded the square brackets, but I kept the normal brackets the same. So this is equal to 3x plus 2 squared plus 7, and this is my final answer. In part of this question, I am given a turning point, and I need to find this turning point under two transformations. The first one, f of x plus 5, translates the graph by 5 units upwards. Hence, the x coordinate remains the same, and I add 5 to the y, so I get 1. The second one, f of 3x, divides the x coordinates by 3. So the x coordinate becomes minus 2 and the y coordinate stays the same. For the next part, I'm given y equals g of x. I don't know the equation. I need to sketch y equals 2g of x for these x coordinates. So ignore any x less than minus 1 or more than 7. Now I will take 3 points on this graph, and I will find their image under this transformation. So let's write those down. So under this transformation, I'll have to multiply the y values by 2. So the first one becomes minus 1, 6. Second one becomes 3 minus 2. And the last one becomes 7, 6. So now if I plot those 3 new points and then join them using straight lines. In part C, I have a graph that cuts the x-axis at 2 points, minus 1, 0, and 0, and I translate this graph using horizontal translation of A units, and this is mapped to 2, 0. So either the first one goes to 2, 0, and this is by moving it 3 units to the right, or the second point, 6, 0, translates to 2, 0, in which case it has moved 4 units to the left. Now, if the graph moved 3 to the right, it means that A must be minus 3. But if the graph moved 4 to the left, then A must be positive 4. And these are the two possible values of A. In question 21, I have a histogram. And usually when you have a histogram, you either recreate the frequency table or you work with squares and you count and measure the area. I'll reproduce the frequency table. So here it is, I'm going to create the table. Now I've taken the weight boundaries from my graph. Now I know that for the category 8 to 8.5, there are 16 watermelons, so the frequency is equal to 16. Now I can complete the class width column. This is the difference between the upper bounds and the lower bounds of each interval. So I get 1, 0.5, 1, 1, and 1.5. And then I'll have to find the frequency density, which is given by the following formula. That's frequency over class width. Hence, the frequency density for the 8 to 8.5 category is 32. So if I go to my histogram, this height here is 32. So now I can complete the vertical scale. That's 5, 10, 15, 20, 25, 30. So for each bar now, I can read off their height and complete the frequency density column. So let's complete it. 15, 32 is already there, 23, 30, and 12. And if I rearrange this formula, frequency will be equal to frequency density times class width. So my frequencies will be 15, 16 is there, 23, 30, and 18. And if I add this up, I will get 102, and that's my final answer. For question 22, to find B, I'll need to use the sine rule, which says that B over sine B is equal to C over sine of C. And if I rearrange this, I'll get B is equal to C times sine B over sine of angle C. And now just replace angle C with Y, so C times sine of B over sine of Y. Now, since I want the upper bound for B, I'll need to multiply the upper bound of C times sine of the upper bound of B divided by sine of the lower bound of Y. I need my numerator to be big and my denominator to be small. Now, for angle B to be large, the two other angles, x and y, must be small. This is also confirmed from angle here in the denominator, that has to be small. So to find the upper bound for angle B, I'll have to do 180 minus the lower bound of x plus the lower bound of y. Now let's go and find the upper and lower bounds of these given quantities. Now C is between 11.45 and 11.55. X is between 79.5 and 80.5, and Y is between 74.5 and 75.5. So if I substitute these into here, lower bound of X is 79.5, lower bound of Y is 74.5, which gives an upper bound of B of 26 degrees. So if I go to the right, the upper bound for side B will be given by the upper bound of C, which is 11.55 times sine of the upper bound of B, which we just found to be 26, divided by the sine of the lower bound of Y, which is 74.5. And if you put this on the calculator, you will get 5.25 to 3 significant figures. In question 23, there are basically two phrases that tell us what exactly we need to do. One of them is the r moving, which implies that we need to use velocity, same as speed, and the other one is same direction, which implies that both velocities must be positive or both velocities must be negative. So let's begin by finding the velocities. The velocity is the derivative of the displacement, so we need to do differentiation. ds dt is equal to 3t squared minus 8t plus 5. I will set this equal to 0 and then factorize 3t minus 5, t minus 1, and then equal to 0. So t is 5 over 3, or t is equal to 1. So if I try to plot this graph on a t-axis, it will look like this. Note that the derivative is positive to the left of 1 or to the right of 5 over 3, and it's negative between 1 and 5 over 3. If I go to particle Q and differentiate, I'll get dx dt is equal to t minus 4. Again, I will set this equal to 0, so 2t is 4, t is equal to 2. Let's draw again a t-axis. Now note that if t is bigger than 2, 2 times t and then minus 4 will give me a positive number. If t is less than 2, 2t minus 4 will give me a negative number. So now that I have established where each derivative is positive and where it's negative, let's collapse this into a single table with the 3 cutoff points, 1, 2, and 5 over 3. ds dt is positive to the left of 1 or to the right of 5 over 3. Hence, it's negative between 1 and 5 over 3. dx dt is positive to the right of 2, and it's negative to the left of 2. So, if I go back again, I need both to be positive or both to be negative, and this happens between 1 and 5/3 or for t bigger than 2. So final solution, t is between 1 and 5/3 or t is bigger than 2. In question 24, I'm given that OX is equal to A. M is the midpoint, hence OM and MX are a half A. XY is equal to B and OZ is equal to 3B. I'm also given that ON to OY is lambda to 1. So this is like saying ON is a fraction lambda of the whole line. And I will assume that mu n is a fraction of mu of the whole line mz. The strategy here is to choose any starting and finishing point and find two different routes from the starting to the end point, create two equations and solve them simultaneously to find lambda and mu. My starting point will be O, my end point will be N, although you can select any 2 points you want. And the two routes I will go through are the direct one and the one that goes through M. I'll start with the direct route, so ON is equal to lambda OY. This is equal to lambda OX plus XY. So lambda times OX is equal to A, XY is equal to B. If I expand, I'll get lambda A plus lambda B. The second route will be the one that goes from O to M and then M to N. OM is 1/2A plus an MN is mu times MZ. So a half A plus mu, and MZ is equal to MO plus OZ. So 1/2A plus mu. MO is equal to minus 1/2A. I'm going 1/2A backwards, plus 3B. Let's expand. 1/2A minus a half mu A plus 3 mu B. And I'll factorize the A out. So A 1/2 minus 1/2 mu plus 3 mu B. So now I can equate the coefficients of A. So lambda will be equal to a half minus a half mu. And I will also equate the coefficients of B. So lambda will be equal to 3 mu. So for the coefficients of A, lambda is equal to 1/2 minus a half mu. Coefficients of B, lambda is equal to 3 mu. I will substitute this into here. So 1/2 minus 1/2 mu equals 3 mu. I'll take the minus a half mu to the other side. So a half equals 7/2 mu. And if I divide 1/2 by 7/2, I will get a value of mu of 1/7. And because lambda is equal to 3 mu, lambda will be 3 times 1/7. So lambda will be 3/7, and that's my final answer.